What's good, y'all? We're still talking about factoring. In this problem, we're actually going to see how to factor a quadratic equation using a technique that I learned from a Math 105 student. I'm super excited about this. Let's get started. Let's pretend we're walking down the streets of Mountain View. Local math thugs are on the beat. They come up to us and they throw this problem. Before we run, we say to ourselves, all right, I got this. I'm going to go back to my Math 105 training. Every single time I'm looking at a math problem, I'm going to read the entire problem statement out loud to myself real slow. So back up, punks. Use an algebraic technique to solve m squared minus 40 equals 3m. Let's take a deep breath. I'm feeling a little nervous because I'm feeling like I got hit in the face again. That math seems to do that to me. After we've read the problem, we ask ourselves the same question we ask every night. Is there an equal sign? In this case, we see the equal sign right there, and we say to ourselves, when there's an equal sign, we're going to solve the equation. As always, we're going to go ahead and write the original equation from the problem statement in our own handwriting because you are the best mathematician in your life. There's no mathematician better than you. When you write it in your own handwriting, you're really bringing it to your home turf. The next thing I want to call out is this cuadro right there, that square. The fact that that's a square means this is a quadratic equation, and we're actually going to use something called factoring. In order to factor, we're going to get this quadratic equation in standard form. Do you remember standard form from the last video? One of the sides is always equal to 0. We're going to get this side right there equal to 0. In order to do that, let's bring that 3m over to the other side. In this case, it's positive. How do I get a positive over to the other side? Well, I annihilate that positive by bringing it this way. Positive 3m minus 3m, of course, would be 0 because plus and minus annihilate each other. The m squared and the m don't mix. The 40 and the m don't mix. These are all different terms. Now I've got something that looks like m squared minus 3m minus 40. And this is where I like to really encourage my students to go out on a limb and do a little bit of extra work because it pays off in the long run. In particular, we recall that the standard form of a quadratic equation has this a in front of the squared term, the b in front of the linear term, and the c constant. Well, in this case, the variable is not x, it's m, so that's a little bit confusing. But we ain't tripping. We're going to tell our teacher, you can't fool us, son. I got this. So in particular, the number in front of the squared term, we're going to call 1. Because we can always multiply something by 1 and not do anything. It doesn't change when we multiply by 1. The coefficient in front of the degree 1 term, hella nerdy. The number in front of the m term or the x term, well, we would say 3, except that's stupid negatives right there, and we want a positive. But we remember that we can write any negative as plus a minus. In particular, the b term we're going to write as negative 3. Same thing right here. The constant term, c, we can write as negative 40. The standard form requires a positive. When it's negative, we just group that negative into the term itself. Now that we have the a, b, and the c, we're going to do something called the AC method. I learned this from one of my algebra students way back when. I don't want to say how many years ago because I still like to pretend that I'm young, even though my kids are making me lose my hair. In the AC term, we're going to write this little x. And I remember the guy that told me about this, he used to call it the great X, and that made me really laugh. In the great X, on the top, we're going to write A times C, and on the bottom, we're going to write B. Right above A times C, we're going to write multiply. Right below B, we're going to write add. In particular, this is the general form. Let's do it for this specific example. Usually I only do this once, but because this is the first time I've really talked about it, I'll do it twice. The technique's so nice we did it twice. A times C, 1 times negative 40, well that would be negative 40. And then here the B term would be negative 3. And now we're going to solve the following problems. We want two numbers that multiply to negative 40 and add to negative 3. Let's see what we got here. We know that negative 40, one way to write that is negative 4 times 10. If we add those together, we don't get anything close to 3. Another way to think about this, well, what if we were to think, 8. Well, that's kind of nice. 8 times 5? 8 times 5 is definitely 40. I have a negative on one of them. I'm going to add those two factors together to get negative 3. Well, check this out. If I add negative 8 to positive 5, I definitely get negative 3. Let's go ahead and write that. Negative 8 plus 5. And more specifically, I know that negative 8 times 5 is indeed negative 40. You might be wondering what we're doing here. The whole idea of the AC method is to actually undo something that we called before as combining like terms. In particular, this middle term, which was negative 3, we're going to now split it into these two terms. Here we write m squared, negative 3m, well that's going to be negative 8m plus 5m minus 40 equals 0. I had another Math 105 student that used to call this split the middle term. And I always kind of smiled when I heard her say that. I'm telling you, I've said this out loud before in class. My students teach me mathematics. This is legit. I learned this whole method from a student, and I learned the name for the method from another student. Now that we've used the AC method to split the middle term, the next thing that we're going to do is something called factor by grouping. In particular, once we have this 4-term statement right here, we're going to group the first two terms together and group the second two terms together and see if we can factor each separately. In the first two statements, notice that both terms share an m, and we can factor that m out. M out of m squared is m out of negative 8m is negative 8. On the other hand, I can factor out, in this case it looks like a 5. 5 out of 5m would be m left over. 5 out of negative 40 would be negative 8. Notice I haven't done anything over to the right-hand side of that expression. Here's something crazy. This right-hand side right there is the exact same expression as the right-hand side over there, and we can undo right distributivity. We can actually factor that out. When we do so, we see that this leaves m plus 5 times m minus 8 equal to 0. Now we have an equivalent equation where the quadratic expression on the left is factored. And check this out. You remember way back when? I feel like I need a pipe and a beard. A beard so I can stroke and look smart, and a pipe so I can have a little bit of fun while I'm doing it. When I'm looking at a times b equals 0, what did we say when we multiply two things together and we get 0? What property do we have for zero products? Yeah, the zero product property. Remember, we said that if a times b equals 0, that means either a is equal to 0 or b is equal to 0. Well, in this case, the first term, the thing right there, the first factor of my product, that we'll think about as the a. The second factor we'll think about as the b. We can immediately annihilate that multiplication. We can undo it using the inverse operation, which is called the zero product property, and set either m plus 5 equal to 0 or m minus 8 equal to 0. But what would you say if I gave you either of those equations? You'd probably be like, I'd do that in my sleep, sucker. Because you do. You look at this. Take the 5 over to the other side. In this case, we've got something like plus 5 minus 5 disappears. 0 minus 5 is minus 5. In this case, to get the 8 over the other side, we add 8. Minus 8 plus 8 is 0. 0 plus 8 is 8. We're not quite done because we haven't checked our work, but we could actually do this systematically. Remember that in the original equation, we had this m squared minus 40 equals 3m. Let's go ahead and check whether or not m equals negative 5 solves this. Everywhere we see an m, we're going to drop a negative 5 into that. Here we've got negative 5 squared would be something like 25, right? Because negative times a negative is a positive. 5 times 5 is 25. We haven't done anything with the 40. 3 times negative 5 would be negative 15. 25 minus 40 is indeed negative 15. Today is Sunday. It must be the case that negative 15 equals negative 15. We'll check that out. Let's go ahead and drop that mic. Yep, we did it. All right, let's check this one over here. We go ahead and drop the m equals 8 into that equation to make sure we're not smoking anything. Or if we are, that we're having a little bit of fun doing it. In this case, everywhere we see an m, we're going to drop an 8 in there. And then here we've got 3 times 8. 8 squared, I think, is 64 minus 40. 3 times 8, I deed is 24. 64 minus 40 looks like 24. Again, it's Sunday today. 24 is indeed equal to 24. We'll check that out. These are both solutions to our equation. Before we move on, let's just do a quick review. First thing we did to get those math thugs off our back is we actually read the equation in the entirety real slow. Then we asked ourselves that famous question, is there an equal sign? In this case, there is. We're going to solve the equation. We classified it as a quadratic because we saw that square. When we solve quadratic equation via factoring, we're going to get the right-hand side of that equation equal to 0. In other words, we're going to put the quadratic equation in standard form. I always suggest that we specifically identify the values for the a, b, and c coefficients. When it's just a squared term and nothing's written in front, that will be 1. The a will be 1. The b term will be the one in front of the variable with no power. In this case, it was negative 3. And the c will be the constant. In order to split up this term, in other words, undo combining like terms, we're going to use the AC method. Remember, in the AC method, we're going to draw a little x for ourselves. We put a times c in the top, write the words multiply right above that. We put b in the bottom, we write the word add. And then we're looking for two numbers that multiply to negative 40 and add to negative 3. In this case, we chose negative 8 and positive 5 because those solved those two problems. Once we did this, we realized that this gives us an equivalent way to talk about negative 3m as negative 8m plus 5m, which lets us split that middle term. We literally just break it apart. Once we've broken it apart using that equivalent version, we can do something called factor by grouping. We group the first two, factor something common out, group the second two, factor something common out. Lo and behold, we actually can factor the entire polynomial. The reason that that's really nice is this is now in the form a times b equals 0. That's the exact form that we want in the zero product property. We know how to annihilate that multiplication by just setting one of the two factors to 0. And that's exactly what we've done here. In other words, we've transformed a quadratic equation into two linear equations where the product disappeared. The only cost was we needed to get the right-hand side to 0, and we needed to write the left-hand side as a product of two terms. That's called factoring. Last thing we did is we solved those kind of straightforward linear equations. We got two solutions and we checked. This pattern is going to hold for all of factoring. Don't worry, there's a lot going on right now. We're going to get more practice, which is exactly what we're going to do in the next video. I'll see you there.